Our task here is to find the derivative of the natural log function. So we'll do this first by starting with using the limit definition for finding the derivative. We've got d dx of ln x is the limit as h approaches 0 of f of x plus h, that would be the natural log of the quantity x plus h, minus f of x, which would be ln of x, all over h. So first we just applied the definition of derivative. Now we'll use one of the logarithm laws to combine the two logs in the numerator as one. Well, we've seen in the past that if you have the difference of two logarithms, that is the logarithm of the quotient. So this can be written as the limit as h approaches 0 of the natural log of x plus h over x all over h. Now we're going to divide the denominator and the argument of the log function into each term of the numerator of the log function, i.e. we're going to divide this x into both the x and the h by the distributive property. So this limit now becomes the limit as h approaches 0 of the natural log of 1 plus h over x, and then that whole thing is over h. We are now going to get this limit to look like the limit that produces the natural constant e, which was the beginning of these notes. So to do this, we're going to make the substitution v equals h over x in here. Since v goes to 0 when h goes to 0, and h goes to 0 when v goes to 0, we can replace the limit as h approaches 0 in our limit up here with the limit as v approaches 0. So let's do all this substitution. So instead of limit as h approaches 0, we're going to have the limit as v approaches 0. Then we've got the natural log of 1 plus, in place of h over x, we're going to put v. And then also, since v is equal to h over x, we can rewrite that as h equals vx. So in place of h here, we can put vx. So we're going to have the limit as v approaches 0 of the natural log of 1 plus v over vx. Since our limit is now with respect to v, we can pull out the 1 over x in front of the limit, i.e. the limit with respect to v does not affect the 1 over x, hence it can be pulled out front. So we've got 1 over x times the limit as v approaches 0 of the natural log of 1 plus v over v. And remember, this is simply 1 over x times the limit as v approaches 0 of 1 over v times the natural log of 1 plus v. With having rewritten the expression like this, you might notice that because we have a logarithm multiplied by an expression, that this thing can move up into the exponent of the argument of the natural log function. That's one of our logarithm laws, and that's what we're going to do next here. So we've got the limit above is, we got 1 over x times the limit as v approaches 0 of the natural log of 1 plus v, that quantity to the 1 over v power. Now remember, our objective here is to create the limit that would yield the natural constant e. And technically, if we had the limit as v approaches 0 of just 1 plus v to the 1 over v, that would give us the natural constant e. However, we've got this natural logarithm in here. We can't pretend that it's not there. So we're going to use the limit law for composite functions to create the limit at the beginning of these notes that produces e. And the limit law of the composite functions basically allows us to rewrite this as 1 over x times the natural log of the limit as v approaches 0 of 1 plus v to the 1 over v power. Now we have intact exactly what we were looking for. This right here is, in fact, the natural constant e. So we can rewrite this expression as 1 over x times the natural log of e, and the natural log of e is precisely 1. So this is equal to 1 over x. Through a series of guided steps, we have now shown that the derivative of the natural logarithm function with respect to x is, in fact, just 1 over x. This is a very important derivative that you should know off of your head. That is, the derivative with respect to x of the natural log of x is in fact just 1 over x. Now, what about the other base logarithms? Remember, base or natural log of x is base e logarithm. What about any base a logarithm? What would that derivative look like? Well, in order to get the derivative of any base logarithm, we can apply a log law and this derivative we just got to get that formula. So, using the log laws, we know that this thing is equal to the derivative with respect to x of log base a of x can be rewritten as the natural log of x divided by the natural log of a. That's the change of base formula for logarithms. Now, since we're taking the derivative with respect to x of the natural log of x, this factor of 1 over the ln of a is not affected by the derivative. Hence, you can pull that thing out front. So we've got 1 over the natural log of a times the derivative with respect to x of the natural log of x. And we just saw the derivative of the natural log of x is 1 over x. So this is simply 1 over x times the natural log of a. So the derivative of any base a logarithm is 1 over the quantity x times the natural log of that base a.